All right, so real quick on the quadratics review, we're going to go through and work each problem. We'll start with 1, go to 3, and then we'll just kind of bounce around. That way we're not doing a lot of scrolling. So starting out with problem number 1, it says that we have S equals 4 pi r squared. So when you're solving this, the first thing we want to do is we want to divide both sides by 4 pi. The 4's cancel out and the pi's cancel out. And that's going to leave me on this side, S divided by 4 pi is equal to r squared. So to get rid of the square, all we're going to do is take the square root of both sides. And we're going to be left with, on the left side, the square root of S divided by 4 pi. And that's going to be equal to the square root of r squared is r. So with this problem, we're doing a two-step equation. Since these are multiplication, we do the inverse, which is division. And then the inverse of a squared number is taking the square root of both sides. In problem number 3, we had a pretty easy problem there as well. Remember that the leading coefficient is going to be the number that is out in front, or the number that is in front of the x squared. So here the leading coefficient is 4. The constant is the number that stands by itself. So the number by itself here is going to be positive 1. And then the coefficient of the x term, that's going to be the term in the middle, which here is going to be negative 3. So a really easy problem there. Just make sure you can identify all 3 parts and notice the differences in these 3 when you're on the test. Number 2, sorry. Going back to number 2, it says sketch a graph of the quadratic function with a positive. The key here is knowing that the positive is leading coefficient, and then it has the zeros of 4 and negative 1. So here I'm going to graph negative 1. I'm then going to graph 1, 2, 3, 4. And then I also know this is positive, so it's going to open upward. So it should look something like this when I graph it. So that information gives me a starting point. So if I want to find the halfway point between these 2 points, I first need to find the distance. So here this is going to be 1, 2, 3, 4, 5 wide. So half the distance there would be 5 divided by 2, which is going to be 2.5. And then I can count that distance out. So that's going to be 1, 2, and then a half. So that means my axis of symmetry is going to run all the way up and down at 1.5. So that tells me about AOS. So I can figure out the vertex by knowing the AOS, which is going to be 1.5. And then I need to substitute the other number back into the standard form to get the rest of this problem. But before I can do that, I have to do the intercept form. So let's move down to B, and then we'll come back to A. So for B, it says write the function in factored form or intercept form. So just a review over intercept form, that's going to be y equals a, parentheses x minus q, and x minus p. You can write those either way. I know I've been writing in p and q, so you can write it either way. And then all I need to do is just fill in the information. So we know this is going to be a positive a value. In this case, it's either going to be positive 1 or negative 1. So since it's positive, it's a positive 1. So we can leave a positive 1 out in front. And then the q and p are going to be these x-intercepts. So that's going to be your negative 1. So since this is negative q, we're going to make it positive 1. And then since this is negative p, we're going to make it negative 4. So we just take the opposite of what those are to get the intercept form. To get the standard form, we just multiply this out. So if you wanted to, you could do box strategy or a FOIL here. So to work this out, I've got x plus 1 and x minus 4. So x times x is going to give me x squared. 1x plus negative 4x is going to give me negative 3x. And then 1 times negative 4 is going to be negative 4. So that'll take it to standard form for me so that I can then figure out what my vertex is. So taking this equation, I'm then going to substitute in 1.5. So coming back up here to the top, I'm going to have y equals 1.5 squared minus 3 times 1.5 minus 4. So when I substitute that information into the calculator, I can solve it out, and I should get an answer of negative 6.25. So what that tells me is that on my axis of symmetry, I'm going to need to go down 1, 2, 3, 4, 5, 6, and then a quarter. So there's where the vertex is going to be located. Now, once I have 3 points, I know that this is opening up, so I can make my line curved. make sure it passes through all the points, and then I have a perfect graph of this problem. Going back to number 4. Number 4 wanted us to identify the interval of increase and the interval of decrease. So to determine if this is increasing or decreasing, first thing I would find is the axis of symmetry. So here the axis of symmetry, it looks like it's actually really, really close to 5. It may be a little bit less than 5, but let's call it 5 here. So we're going to say that this is our axis of symmetry, and that the furthest the graph can start over here, I think I put arrows on the end. So this could continue if you wanted to. You don't necessarily have to continue it. If it was stopping here, you could say it started at 0 and ended at 10, but it's up to you. So here we're going to put arrows on the end of it and say that it starts at negative infinity and ends at positive infinity. So that would mean that our first interval is going to be from negative infinity all the way to, in this case, 5. And then our second interval is going to be from 5 to positive infinity. Now, once we know our intervals, on this interval we start here, we go up. So we can see that this is going to increase up till it gets to the top. So this would be your interval of increase. And then on the other side, this would be decreasing or going down. So this would be your interval of decrease. So there's your decrease, here's your increase, and you can find your answers by going through that process. It's pretty easy, not too bad. All right, after number 4, we then have number 5. Number 5 wanted us to write this in vertex form. So remember, vertex form looks like this. Y equals A, parentheses, x minus h, squared plus k. So in this problem, we need to know A, h, and k. All right, so to write this in vertex form, so I need to identify what my vertex is going to be. So in this problem, all I'm going to do is figure out A, h, and k. So we already know A is equal to 1. We also know h and k are going to be found by using negative b over 2a since this is in standard form. So to find h, we're going to use negative b over 2a. So that's going to be negative times b, which is negative 6, divided by 2 times a, which is 1. So that's going to give us a 2 on bottom. Negative times negative 6 is positive 6, which gives us an answer of 3 for h. To find k, all we do is substitute back in. So to find k, we're going to say x, which is 3, squared minus 6 times 3 plus 10. So working this out, we know 3 squared is going to be 9. And then we have negative 6 times 3, which is negative 18, plus 10. So when we solve that, 9 minus 18 is going to be negative 9. And then negative 9 plus 10 is going to be positive 1. So from there, we can identify that the k value is going to be 1. So that gives us our h and our k, and then our a is up here at the top. So to write this in vertex form, we would have y equals a, which is going to be 1, parentheses x minus h. So h here is 3, so negative h would be negative 3 squared, and then k is going to be positive 1. Over on the right-hand side, number 7, it wants you to solve that question. So the first thing I need to do before I solve this is I'm going to subtract 12 from both sides and get this equal to 0 and move the 12 over. So that's going to give us x squared plus 4x minus 12 is equal to 0. From here, I would be able to solve this in the quadratic formula. So quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. So when I substitute in what I know a is 1, I know b is 4, and c is negative 12. So here I'm going to have negative b is 4 plus or minus the square root of b squared, which is going to be 4 squared, minus 4 times a, which is 1, c, which is negative 12. And then that's all going to be divided by 2 times a, which is 2 times 1. So when I solve this down, negative times 4 is going to give me negative 4. Then I've got plus or minus. 4 squared is going to give me 16. Negative 4 times 1 is negative 4. And then negative 4 times negative 12 is going to give me positive 48. So that's going to be 16 plus 48. And 16 plus 48 is going to be the square root of 64. From here, 2 times 1 is going to be 2. So then I can simplify this down to negative 4 plus or minus square root of 64 is 8 divided by 2. So this becomes two problems from here. All I'm going to have is I'm going to have x equals negative 4 plus 8 divided by 2. And I'm going to have x equals negative 4 minus 8 divided by 2. So negative 4 plus 8 is going to give me 4. 4 divided by 2 is 2. So there's one of my solutions. And on the other one, negative 4 minus 8 is negative 12. Negative 12 divided by 2 is negative 6. So two simple solutions, but we do need to make sure we know how to do that in case there is a non-calculator question on the test. So make sure you know how to do the quadratic formula in case you do not have a calculator. Number 6 and number 8 you will have a calculator for, but you do need to know how to set this up. So in number 6, it tells you that you have a picture, and the picture has a length of 6 inches and a width of 4 inches. It also tells you that there is a picture frame all the way around, and we do not know the size of that picture frame, so we're going to say that it's going to have extra length and width of x. And that's all the way around. So x plus 6 plus x will give us the length on this side, which is 2x plus 6. And then on this side we've got x plus 4 plus x, which is going to be 2x plus 4. The other thing that we know is that it has a area of 63 inches squared. So what we can do, since that is area, we can say area equals length times width. And then we can take and actually fill in what we know. So area is going to be 63 equals length is going to be 2x plus 6. And then the width is going to be 2x plus 4. So to solve this, we just multiply it out. So that's going to be 2x times 2x, which is 4x squared. 6 times 2x is 12x. 2x times 4x is 8x. So 8x plus 12x is 20x. And then negative 6 times 4 is going to be 24. To get this equal to 0, we want to subtract 63 from both sides. And we get 0 is equal to 4x squared plus 20x minus 63. Now, from this point, we can plug into our calculator, because you will have a calculator at this point. So I would use mode 5, 3. And then enter in your numbers. So here your numbers would be 4, 20, and negative 63. So you will be able to use a calculator on the test tomorrow, so I strongly suggest that. If you don't have a calculator, then you can do the quadratic formula with these numbers to figure out the answer. So once you plug this into the calculator, you should come up with two answers. I believe you get x equals 1.5, and on the other answer you get x equals negative 6.5. So here we do not want to go with a negative answer because we can't have negative distance. So x equals 1.5 will be the correct answer. Now, question number 8 is also very similar to this because it's dealing with an equation, and it wants to know how long it will take the object to hit the ground. So remember that when you have an object hitting the ground, you've got something coming up and hitting the ground, it's hitting the ground at x-intercept. If it wants to know the total or the maximum height, then it's going to be the vertex. But here we're looking for the x-intercept. So to do this one, once again, mode 5-3. And then enter in your information. So here it's going to be negative 16, 64, and 190. If you don't have a calculator, you can do that using the quadratic formula. But take and insert your numbers. And all right, so when we solve that, we should get two answers. We're going to get x1 equals, and if you change it to a decimal, you can get 5.98. And then the x2 answer on the calculator is going to give you negative 1.98. So same concept here. Our time cannot be negative, so we know that's not the answer. So here the correct answer would be 5.98. So make sure you round that with your calculator. All right, we're about to run out of time on this video, so I'll start a second video in a second so that you can find out the answers to numbers 9 and 11. So we'll jump down to number 9 and 11, see if we can get those worked out for you, and try and go all the way through 17. Sorry guys, there's a mistake right here. We'll go back to this is number 6. So on number 6, when we subtract these two,